Hello, teacher. Hello, students. Welcome to today's lesson on relative velocity. In previous grades, you studied relative velocity in one dimension. In today's lesson, we will review the meaning of relative velocity. We will also learn how to calculate relative velocity in two dimensions. Students, if you are ready, let us begin. At the beginning of the unit, we studied the importance of having a frame of reference. Do you recall this lesson, class? To explain the concept of frame of reference, we discussed an example of walking down a road, passing by a friend's house, and meeting a neighbor. If you recall, each individual observed these motions differently. They also would have observed the velocities of the motions differently. The velocity of an object is given as noted by an observer. If the observer is stationary, then the velocity is referred to as absolute velocity, or simply as velocity. On the other hand, if the observer is not stationary, the velocity is referred to as relative velocity. That is to say, it is the velocity of the body relative to the moving observer. Let us begin today's lesson with a review activity in which we will determine relative velocity in one dimension. Two trains are running on parallel straight tracks in the same direction. Train A, moving with a speed of 30 meters per second, overtakes train B, which is moving with a speed of 20 meters per second. If the train lengths are each 200 meters, then find the time elapsed and the ground distance covered as one train overtakes the other.
Students, let's get ready. Time's up. Let's get back to our lesson.
Hello again, students. I wonder if you had any difficulties with this activity. Let us look at the answers together. Because the trains are moving in the same direction, the relative velocity with which train A overtakes train B is found by subtracting their velocities. Thus, the relative velocity equals 10 meters per second. The total distance that must be covered is equal to the sum of the length of each train, which is 400 meters. The time required for train A to overtake train B is found by dividing the displacement by the speed. 400 meters divided by 10 meters per second equals 40 seconds. Finally, to determine the total ground distance covered by the two trains during the overtake, we multiply the speed of train A by 40 seconds and add it to the speed of train B multiplied by 40 seconds. As train A overtakes train B, the total ground distance covered is 2,000 meters. If your answers were the same as these, then you have done very well. We calculate relative velocity in 2 dimensions in much the same way. If the observer is not stationary, then to find the velocity of body B relative to body A, we subtract the velocity of A from the velocity of B. However, because the motion is in both the vertical and horizontal dimensions, the relative velocity will be the vector sum. Suppose that a river flows to the north at a velocity of 2 meters per second. A ferry is crossing the river from west to east. The velocity of the ferry relative to the shore is 4 meters per second. In vector form, the velocity of the river is 0, 2. The velocity of the ferry is 4, 0. To calculate their relative velocity, we subtract, and the difference is -4, 2. We can use the parallelogram theorem to find the magnitude of relative velocity. The square root of -4 squared plus 2 squared is about 4.5 meters per second. The direction of the relative velocity is found by taking the inverse tangent of -4 over 2. We get 63 degrees. So, the velocity of the ferry relative to the current is 4.5 meters per second at an angle of 63 degrees. Students, now it is your turn to determine relative velocity. A car is moving at a speed of 10 meters per second east along a straight road. It begins to rain with a velocity of 15 meters per second in the vertical direction. How is the rainfall's velocity apparent to the driver as it hits the car's windscreen? Be sure to solve for both the magnitude and direction. You may begin, students.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Hello, everyone. How did you do? In vector form, the velocity of the rain is 0, -15. The velocity of the car is expressed as 10, 0. Because we are trying to find the velocity of the rain with respect to the car, we subtract 10 from 0 and 0 from -15. Therefore, relative velocity is -10, -15 meters per second. The magnitude of the relative velocity is found to be 18 meters per second. Inside the car, the rain appears to fall, making an angle theta with the vertical or y direction. The direction of the rain is the inverse tangent of -10 over -15, which equals about 34 degrees. Was this your answer, students? Great work. Today, we reviewed the meaning of relative velocity, and we learned how to find the velocity of one moving object relative to another in 2 dimensions. Until next time, thank you, teacher. Thank you, students.